In the previous lesson, you understood what a system in equilibrium means. If I have defined reactants and the reaction is reversible, then over time, this reaction will reach equilibrium where there is no net change in the concentration of products and reactants. Great, so now let's say we have a system at equilibrium. Let's say I have a gaseous system of nitrogen, hydrogen, and ammonia. Nitrogen and hydrogen will react to give you ammonia gas and vice versa. This system is now in equilibrium. And the forward rate of reaction is now equal to the rate of the backward reaction. And there is a certain concentration of hydrogen, nitrogen, and ammonia. What happens if I disturb this system in equilibrium? Or rather, how can I possibly disturb this system? There are a few ways to do it. We can change the concentration of hydrogen, nitrogen, or ammonia, for example, by adding it or removing it from the system. We can change the temperature of the system or the pressure of the system. We could even add a catalyst for this reaction into the system. How will these disturbances affect equilibrium? That is what we are interested in. But let us first understand the general reaction of the system to such a disturbance. Le Chatelier's principle tells us what happens to a system equilibrium when equilibrium is disturbed. And this principle is derived from empirical observations. The system will want to re-establish equilibrium, and it does this in a way by shifting its equilibrium position that allows it to re-attain equilibrium. You can think of this as an analogous example, such as that of you tilting a cup to the side slightly, and it will fall back to its original position. Did I just say shift the equilibrium? No, I said shift the equilibrium position. What is the equilibrium position? Think about it as where the equilibrium appears to be. Just for now, we will go through the idea of equilibrium position in greater detail as we look at real examples of disturbances to systems at equilibrium in the next few checkpoints.